Good day, everyone. This is the continuation of differentiation, and here the focus will be on techniques of differentiation. Under these techniques of differentiation, we are going to consider composite function using chain rule, and also is known as function of function. Then also product rule and quotient rule. Each of these will be taken one after the other, and I want to pay rapt attention and try as much as possible, having watch a stage, try to practice. When you watch a stage, try to practice so that this one will ensure absolute mastery. Thank you. Now, composite function. An example of composite function. We want to find the y-ds of this function. To find the y-ds of this function, I want you to know something on composite function. Composite function is embedded function. It's like a function that you cannot separate, but you can try to make it simpler. That's why they call it function of function. Some people call it chain rule, but the basic name is composite function using chain rule because it's like a chain. Now, if you look at that bracket, inside the bracket we have 2x minus 5, then raised to power 3. So what inside the bracket, we can use something to represent. Universally use u. So let's say u is equal to 2x minus 5. If u is equal to 2x minus 5, it means that y is equal to u raised to power 3. Then you can differentiate u by having the u dx, which is 2, and differentiate y in respect to u, and by having the y du, which is 3u squared. Then the y dx will be the u dx multiplied by the y du, which will give you the multiplication of this one and this one, and it will give you this. So the answer is 6u squared. Note, you can't write your final answer like this. If you write your final answer like this, it means you are not yet true. Why? Because u is not in the original question. So we need to take u and replace. This is your u, which is equal to 2x minus 5. Then we need to you substitute the original value of u and have this as our final answer. Another one. Y is equal to 1 over square root of 6x minus 1. We need to rewrite this question in a way that's very easy for us to solve. So we can write this as 1 over 6x minus 1 raised to power half. We still need to repackage this question again. So it will be 6x minus 1 raised to power minus half. In this place, our u is 6x minus 1. Our y is u raised to power minus half. Then we can differentiate the first one, u in respect to x, having the u dx, and also y in respect to u having the y du, which will give us then the y dx be multiplication of the two, which will give us this. Now just repeat what I have in the previous slide now. In this place, you can multiply 6 and by that minus half u raised to minus 3 over 2, and we have this. Note, u is not part of the original question, so we need to replace u again by 6x minus 1. And you can leave your final answer like this, or you can write your final answer like this. Whichever you write is okay. Whether you leave your final answer like this, you are okay, or you write it like this, you are equally okay. Now, product rule. Product rule. In product rule, you have two functions that are multiplied. You know the name product. Product means we have product of two numbers, a number multiplied by another number. Now, when you have a product rule, y is equal to uv. U is a function, v is another function. Then the y dx will be v the u dx plus u the v dx. If you write your own as u the v dx plus v u plus v the u dx, you are equally correct. Because, you know, in binary operation, we call something closure. Addition is going to say x plus y or y plus z, they are the same thing. So if you write v is equal to du dx plus u the v dx, or you write the y dx is equal to u the v dx plus v the u dx, both of them are correct. So example, y is equal to 3x squared in bracket 5x minus 2 raised to power 3. We want to find the y dx. So to find the y dx, u is equal to 3x squared, v is equal to 5x minus 2 raised to power 3. So we can differentiate the first one, u in respect to x. We have 6x. But look at that v. That v is a composite function on its own. So the idea is like differentiate what you have inside that bracket. You have 5. Then see that what you have inside the bracket as an entity. So let me call it w. So w raised to power 3, that will be 3w squared. So if you multiply all of them together, you have this. So 5 is when you differentiate what you have inside the bracket. Then if you look at 5x minus 2 as an entity, the answer will be 3, that entity squared. Then you multiply the two together and have this as your dv dx. So the y dx is this, as I said, this is the formula for the y dx, and this is our u, the u dx, our v, the v dx. So using the formula to put them together, we have this. This one is our v, this 6x is our du dx, this 3x squared is our u, y 15 bracket 5x minus 2 is our raised to power 2 is our dv dx. So you can try to simplify your answer. The first of all, I rearrange it. You need to rearrange. Don't just write anyhow. Just arrange them in the order of the powers. So I arrange here. In the first part, I put that 6x in the front. I multiply 3x squared by 15, giving us 45x squared. So when I factorize, if you look at the both sides, I can factorize 6x and 45x squared. 3x can go there. I have that 3x outside. Then 5x minus 2, I have raised to power 3, 5x minus 2 the other side, raised to power 2. So raised to power 2 can go in both sides. I have that one, then the remaining one inside that angular bracket. So if I further solve what I have inside that angular bracket, I have 10x minus 4 plus 15x. So in this place, I try to simplify what I have inside the angular bracket as usual. Then I can rearrange. In order of power, we have 3x, 25x minus 4, then 5x minus 2 raised to power 2, which is the one that has the highest power. So the final answer is this. If I open the bracket, but if you leave your final answer like this, you are okay. And if you want to work it further, you can equally write it like this, which is equally okay. Quotient rule. In quotient rule, we have numerator and denominator. Numerator is at the top, while denominator is at the bottom. Now, the y dx for quotient rule, you know that u and v, you just use as a representation that something is at the top, a function is at the top, a function is at the bottom. Because we are differentiating y in respect to x. So the y dx for quotient rule is v du dx minus u dv dx all over v squared. I want you to note that if you write u dv dx minus v du dx all over v squared is wrong. Unlike product rule, quotient rule is strictly v du dx minus u dv dx all over v squared, provided your numerator is u and your denominator is v. I want you to note that one. Now, example. Y is equal to 2x plus 3 raised to power 2 all over x squared minus 7 raised to power 3. So u is the numerator, which is 2x plus 3 raised to power 2. So the u dx is 2. We differentiate what we have inside the bracket, we have 2. That point you see there is multiplication, is not decimal point. Then if you look at 2x plus 3, let us call it an entity. Entity square. When you differentiate entity square is 2 entity raised to power 1. Although when something is raised to power 1, we don't write raised to power 1. We just leave it like that. Likewise, when you have a coefficient of 1, there is something like 1x, x. You know that coefficient is 1. When you have a, you know that coefficient is a. Likewise, when you have a, you know that coefficient is 1 and power is 1. You don't need to write 1a raised to power 1. Therefore, you just need to multiply that 2 and 2, which will give you 4 bracket 2x plus 3. V is equal to x squared minus 7 raised to power 3. So you do the same thing. The V there will be 2x multiplied by 3 in bracket x squared minus 7 raised to power 2. So multiply that 2x and 3 as well, give you 6x, x squared minus 7 raised to power 2. So I put them inside the formula V the U dx minus U the V dx all over V square. So I need to rearrange. So if I rearrange, I put them orderly according to the level of their power. We have 4, 2x plus 3, x squared minus 7 over 3 minus 6x and so on and so forth. Then that denominator, when in English, when something is raised to power something and in bracket and all that, you multiply the powers together. So that 3 and 2 of the denominator multiplied together will give us 6. So we have x squared minus 7 raised to power 6 as the denominator. You can further simplify. Now, in this place, I factorize this one to get this. How do I go? If you look at this 4 and this 6x, or let me say minus 6x, 2 can go in 4 and 2 can go in 6x. So I have that 2 at the extreme. Then we have 2x plus 3 at this side and 2x plus 3 also at this side raised to power 2. So 2x plus 3 can go in both sides. So that's why I have 2x plus 3 next to that 2. Then the third one, if you look at x squared minus 7, we have raised to power 3 here. We too have x squared plus x squared minus 7 this side raised to power 2. So raised to power 2 can go in both sides. So I have x squared minus 7 raised to power 2. Then I have the remaining part of the factorization inside that angular bracket. Then all over x squared minus 7 raised to power 6. In this place, what I have in the previous slide is what I just repeated here. But I want you to know that this one, the angular bracket that is there, I simplify what I have inside the angular bracket. 2x squared minus 6x squared will give us minus 4x squared, then minus 14 minus 9x. Furthermore, if you look at this place very well, you discover that I have x squared minus 7 raised to power 2 or x squared minus 7 raised to power 6. I can cross them out. Why? Because the function at the numerator 2x plus 3 x squared minus 7 all square, and the fourth one, what connect them is multiplication, then divided by x squared minus 7 raised to power 6. So I can divide this one and also divide this one, while the one at the numerator will go, then at the bottom will turn to raised to power 4. Then I can put everything together like this. I can leave this as my final answer, but that second bracket at the numerator, I can rearrange according to the level of the powers. Then I can have this as my final answer. I want to believe that you have learned some things and you will need to try to lay your hand on as many questions as possible for better mastery. And I would like to implore you that you should try to subscribe to this channel so that you can get more, and also click the notification so that anytime I upload any material, it will notify you, and try to share with your friends so that they can be beneficiary of this YouTube channel. Thank you and remain blessed.